All right, so let's look at another example of these. We're going to be following the pattern that I introduced Friday morning when we had class. Okay, and the pattern is establish the geometric relationship between the variables, then take derivatives. All right, that's the pattern. So if we look at this guy, we've got a window. The window is able to open and close like so. It says if the cylinder extends at a certain rate, determine the angular velocity and the angular acceleration. So there's our targets. Okay, we want the angular velocity and the angular acceleration on those things. Okay, it gives us information about the angle, okay, theta, and about this variable s. So we need to relate s to theta. This is where the law of cosines is super duper handy. So let's just set that up over here. So we're going to have s squared is equal to 2 squared plus 1 squared minus 2 times 1 times the cosine, times the cosine of theta, like that. Okay, so we can simplify that a little bit and turn that into s squared is equal to 5 minus 4 cosine theta. All right, there we go. That's our relationship right there. Okay, so once we have that, now we just take derivatives on that thing. Now, derivatives are not necessarily straightforward, but in this case, they certainly are. So we need the derivative with respect to time of s squared. So that becomes a 2s. But remember that s is a function of time, so we have s dot on there. Okay. Now that s dot is going to be this constant rate right here. That's what that's going to be. When we get ready to plug stuff in, we're going to go with that. All right. The derivative of 5 is 0. Then we got minus 4 times cosine theta. So derivative of cosine theta is negative sine theta. So that cancels out. We get 4 sine theta. But remember, theta is a function of time. So we put a theta dot on here just like that. So there is our first relationship. 4s s dot is equal to 4 sine theta, theta dot. All right. So to solve for theta dot, we're just going to put in our values. Okay, 2. We're going to figure out what s is. So let me get my calculator out here. Okay, so I'm going to use the s squared equals 5 minus 4 cosine. That's how I'm going to get that thing. Okay, so it's square root of 5 minus 4 cosine of 30 degrees. Okay, so I get 1.239 is my S value, and I need to write that down somewhere. So S at 30 degrees is 1.239, just like that. Okay, now I'm going to go back to my calculations. So S is 1.239. S dot is 0.5, and that's equal to 4 sine of 30 degrees times my theta dot. Okay, then I just got to solve for theta dot. So let's do that. Theta dot is going to be 2 times 1.239 times 0.5. We divide that all by 4 sine of 30. Okay, so I get 0.6195 for that value. Okay, so it's kind of interesting. It's well, it's good. It's positive, right? Because that means the angle is getting bigger. So it's supposed to do that. So that's good. Now let's go get the angular acceleration. So we've got to take a derivative again. So let me do this one. Say black. Oops. So I'm going to write down my original equation here for us. So 2s dot is 4 sine theta theta dot. 4 sine theta theta dot. So we'll take derivatives of everything. This is going to get a little bit long. So let me scoot over just a little bit. So I've got 2 onto the derivative of s is s dot. So I've got ds dt, s dot, I have to use the product rule, plus s times the derivative of s dot, which becomes s double dot. Okay. Keep going here. I've got 4 onto cosine theta, theta dot, plus sine theta, theta double dot. Sort of like that. Okay. Now, we know s dot. Okay, that's 0.5. Do we know anything about s double dot? Yeah, actually we do. We do because they help us out with this and they say it's a constant rate. So it's not accelerating. S is not accelerating. It only has a velocity term. Okay. So consequently, we can toss that term right there. We don't need that guy at all. Okay. So let me see if I can simplify our expression just a little bit. We're going to have s dot squared, 2 s dot squareds, right? And it's got to be equal to 4. And let's switch it up so it's clearer. Cosine theta plus theta double dot sine theta. Okay. Now we know all of the values. We know s dot, we know theta dot, we know cosine, we know theta. What we don't know is theta double dot, but that's what we're solving for. That's our angular acceleration value. Okay. So let me see. I'm going to put that into a calculator infinity real quick. Get an answer on that. 2 s times 0.5 squared equal to 4 onto. Hey, you can play home. You can play along at home. Can you beat me? Can you calculate it faster than me? 0.5 cosine 30 plus x sine 30. Okay, and so I got theta double dot to be equal to minus 0.616, like that. Okay. Accuracy not guaranteed. Double check it yourself. Shoot me an email if I got it wrong. But again, like I mentioned Friday morning, that's the pattern on these things. Find the geometric relationship, take derivatives, and go from there. Okay? Piece of cake.